It'll take a minute. All right, cool. So hi everyone, welcome to today's APAC community call. And with that, I will share my screen. Should have this open. Can everyone see my screen?
Yep.
All right, cool. So for today's, our agenda is again first to go through the news in the OHDSI, and then we will do kind of play videos from the global community call, a very short 3 mini tutorials on Phoebe, cohort diagnostic, and ATC hierarchy. So those three, I believe, all of the three actually got highlighted, and also kind of during the tutorials before the global symposium, but because of time, I think it was midnight, like Asian time. So I'm not sure if how many people have actually attended the tutorial before the global symposium, because the time just did not really work well for us. So here we'll play kind of the short videos. And then I think if you found that relevant to your work and you found that interesting, and definitely go to the full tutorial from the global symposium to check it out. So with that, I will start on the OHDSI news. So what we have here again from the OHDSI symposium. So everything is now out since we're kind of again like have been 2 weeks or more than 2 weeks. So everything is out. All of the plenary speeches, the presentations. So everything, as you can see here, a lot of the posts are already been out there. And also want to say that because I think we, as APAC region, we have highlighted kind of for the whole year. I think the theme is really we're doing a lot of ETL, we're doing a lot of CDM conversion stuff. So here I think it's really something we want to check out for our for us as well. And also a quick preview that because our first APAC, our second year APAC symposium is gonna take place on November 18th, and the registration and everything will be up shortly. And then I will send out kind of all the blast emails so that everyone can kind of promote in all of the regions, and then we can get the registration and preparation started. So that's a very quick news update, and also stay tuned for the APAC symposium on November 18th. So with that, we'll go to kind of the main part of today's community call. We're gonna play 3 different videos on kind of the 3 parts that got highlighted in the global symposium. But here we'll just do a quick view so that you can see kind of what's out there for those 3 tools. So first one will be Phoebe by Anna.
Thanks a lot for coming. And today I'd like to present you our OHDSI tool, Phoebe, which will help you design better observational studies. So designing an observational study apparently starts with your clinical idea. And when you define your clinical idea, then you want to identify your patients of interest and create cohorts. And identifying patients of interest, of course, starts with creating a concept set. So you want to translate your clinical idea into codes and select relevant codes, and do not select irrelevant codes. Now, the biggest issue with the concept sets, especially if you don't have data or participate in the network study when you have multiple different data sources, is how do you approach creating concept sets. And right now there is no standard, up to the our presentation on the symposium, there was no common standard way to create concept sets. And you can take multiple approaches to that. You can go and search the literature and see what other smart people published on that, and see what codes they use for a clinical idea. But the issue with that is that usually they only use one or a couple vocabularies like ICD-9 or ICD-10 or specific flavors. And these vocabularies may not be applicable to your data source. And then their phenotypes were created on their own data sources. So again, you may not be able to use those concept sets in your data. You can also take another approach and go ahead and create a concept set on your own, and you would go and browse all vocabularies, and you see this huge, large space of dozens of vocabularies, of zillions of concepts, and it's really easy to get lost in there because the space is so huge and you have multiple things and you don't know how to choose from them and whether you should select this concept or that concept. And when you create this concept set, you usually end up, again, with a large number of concepts, and now what? You A, don't even know if you forgot something, and B, how do you figure out if that's the right concept set? Sometimes you send that to your clinicians, and clinicians look at this list of 200 or 300 concepts and go like, what are we supposed to do with that? It's like a large number of concepts. Do you want us to review that? So usually it doesn't go that well. And again, the key issue is that you never know if you did not forget some relevant concepts or included some irrelevant concepts. So what can we do about that? With that in mind, for researchers like us, we created, and by we mean OHDSI community, we created a tool which is called Phoebe, and Phoebe will help you to define your initial starting point in your concept set selection, and then it will help you to modify your concept set to make sure that you included all relevant concepts and excluded things that do not really go with your clinical idea. And to show that, I actually went to Atlas and I browsed with multiple things, what can be used, for example. And I really love a simple disorder that is used in numerous studies as a comorbidity, as an outcome, as whatnot, which is a chronic kidney disease. And here, there is just a simple definition of the chronic kidney disease, which I would like then use in my cohorts. And it's simply one SNOMED concept with all the descendants, so something that you will usually start with. And if you click on the included concepts, you'll see that there is 130 standard concepts, which is already a lot, and 478 source concepts. So it's really, really hard to navigate this space. So how do I make sure that these concepts were good and that I did not forget any of the other concepts that should be in the chronic kidney disease? So what I do is I go to expert, and of course you don't have to use Atlas, I'm just using that because it's easier, and you want to select all the concepts that you want to test. And then I'll show you Phoebe. So it is located on data.ohdsi.org, and then you'll scroll down and there will be this link Phoebe. And you click on that and it will bring you to the tool itself. So again, the tool has two tabs, initial concept and the concept set recommender. For the purposes of this small tutorial, I'm not focusing on the initial concept selection because I kind of already have it in my concept set. But if you are starting from scratch, you may also type in your condition here and it will give you the recommendation on where to start. But we have our list of concepts and we want to test if it's a good concept set. So I will paste my list of concepts into here, into this small box, and it will show me our recommendations. So first, let me navigate you through what we can see here. And the very first thing that you want to do is probably review the concepts that are included in your concept set. And you will go into included, and we'll first focus on these included green things. So what you can see here are the concepts that are included in the concept set with all their details. And then on your right side, you have this highlight, one of the highlights of this tool, which is the record count, database count, and record count and database count with segments. So these numbers are coming from our network study, which has 22 databases and more than, I think, 200 billion concepts in it. So the record count displays the number of records in the network that have this concept. So you can see that and when you order it, you can order it by the record count or by the database count. So what you immediately can see is that the very top concept, end-stage renal disease, has more than almost 300 million records in the network. So that's the most prevalent concept from the concept set. And what this record count gives you is an ability to review this concept set in a meaningful manner, because now you can actually see which concepts are used in the network, and you can prioritize your review based on these numbers. And for example, if you go on the other page, you'll see that there are concepts that are not in the network at all. So probably it doesn't even make sense to review them because they're not used in the patient data. So this provides you a really nice means to review your concept sets and not spend 100 of hours on that. So what I would do is I have this set of included concepts, and I want to go through this list and make sure that all the concepts look nice. Again, depending on your background, it may be a full review if you're a clinician. If not, it can be just a face validity, because sometimes you'll see something that is clearly not right. So I'm going through this list, and the top concepts seems really relevant. End-stage renal disease, chronic kidney disease. So just based on the face validity, everything looks good. And I scroll down, and now I see this concept which says pre-existing, I'm going to highlight it, pre-existing hypertensive chronic kidney disease. Now, that looks suspicious because it says pre-existing chronic kidney disease. And when I created this concept set in mind, I thought of incident chronic kidney disease. Of course, you don't know that, but when you create concept sets, you have some clinical ideas in mind. So I really wanted new onset of chronic kidney disease. And this concept clearly says that the chronic kidney disease was present in mother before that. So that kind of looks not right. And what I really want to do is to exclude this concept just to make sure that I'm not getting prevalent chronic kidney disease. So what I would do, and again, there are multiple options. You can just download the whole data and go through that in Excel file, or you can use APAC. So what I will do is I will copy this concept. We'll go back to my concept set. We'll make a copy. And I will import this concept and we'll exclude it because it doesn't seem that I really want it. So now it's excluded, and I can iterate again for my list. So in the following manner, you'll go through the list of concepts. And you can order it depending on how you want, but essentially record count gives you an idea on how to order it to make sure that you focus on concepts that bring the most patients in the cohort. I will go through that, and it kind of looks fine again because chronic kidney disease, so face validity is fine. And probably at this point, here you go, another pre-existing hypertensive heart disease. So I also want to exclude this. At this point, I really probably want to stop because why bother with the other concepts? They do not really bring any more patients in my concept set or in my cohort. So what else? I reviewed the included concepts. What else can I do? I can also take a look at the other concepts that were not included in the concept set. And you have multiple options. You can take a look at the parents that were not included, and you can take a look at the recommendations. And again, you can order, which is done already, you can order on the record count to get this feeling of what are the concepts that are used in OHDSI network. And I'll go through these codes again and see if I want to pick something. Acute renal failure syndrome does not really match my idea because it's acute, it's not chronic. Then, oh, there is anemia in chronic kidney disease. So that, even without any medical background, that clearly says chronic kidney disease. And for some reason, this concept is not in our concept set. So I definitely want to include that. And again, I will copy that. And you can see that if you look at the numbers, the concept for barium appears in the data sources more than 55 million times, and with the descendants more than 100 million times. So there's a lot of patients that I'm missing in my concept set. So I will click on that, and I will again import this concept with the descendants, and we'll have my updated concept set with the anemia in chronic disease. And then if I go down in the similar fashion, I'll see things that are actually relevant. Like, for example, CPT4 end-stage renal disease services. Again, I may not know what this specific code is, but it says end-stage renal disease. So at least I can include it. And if I'm about to proceed with clinical review, I can show my clinicians those codes and tell them, hey, this looks kind of relevant. Do you want to take a look at that? In the following, in the same fashion, I'll go through all of these codes and we'll stop when the counts are low. And I will update my concept set in Atlas until I feel that this is a good concept set. Now, this tool is all about iterations. When I create my concept set and update it, and I feel that it's fine, what I can do next is I can go to expert and again, click all the concepts, copy all the concepts, go back to Phoebe, paste it again, and look through the list until I feel that the list is really good and I can proceed with that. And also, if you're about to send it to somebody, sometimes people are interested in the source code. So you also have source concepts, and you have like ICD-9s and ICD-10s. So you can also, with the count, you can also give this list to other specialists who may want to review it. And again, the beauty of it is that it has those numbers that really tell you how many records and patients you'll have with this code. So you can prioritize your enormous, huge lists. And people who work with you will are more likely to actually look at them. And of course, it will provide you the recommendations that you missed. Now, you may wonder, okay, it seems that I included all the relevant concepts and made sure that all the included concepts are good. But how do I figure out if the patients with these concepts are the patients that I want? And this will Gotham will talk about how to look at the patients.
All right, thank you, everyone. So that's from Anna on the how do I get out? Anna on the Phoebe for the concept set selection, because I know for sure, like for someone like me, I'm not a medical background. Finding the right concept set can be really tricky sometimes. And the second one is a cohort diagnostic tool. So this was actually rolled out last June, I believe. And then we already have some updates on the tool because I think now we're on cohort diagnostic tool 2 point something. Because last year, when I first learned about it, I think they have made quite some changes to it during the last year. And there's a refreshed version of the mini tutorials by Dr. Rao. So I'll
slides and put it in presentation mode. So the topic of today, 10-minute tutorial, is application of cohort diagnostics to build the outcome phenotype. And the specific phenotype that I'm going to walk you through is the anaphylaxis in relation to drug exposure. So let's quickly talk about anaphylaxis. It's an acute event. It's potentially life-threatening. It can affect multiple systems in the body. Is caused by a sudden release of mast cell mediators into the systemic circulation. And it has these IgE mediated reactions that can be caused by food, can be caused by drugs, can be caused by insect stings. In fact, it can be caused by any agent that is capable of causing this mast cell degranulation. What we are specifically interested here is the drugs part, not the foods, not the insects, not any other forms of anaphylaxis. Now, anaphylaxis is pretty common. One study, a cross-sectional study, showed that the prevalence, lifetime prevalence of anaphylaxis in the general U.S. population is at least 1.6%, and maybe much more. That's pretty high. As part of a phenotyping exercise, we need to understand what this clinical idea is. We need to know what anaphylaxis is, but we should also know what is not anaphylaxis. And anaphylaxis has multiple definitions, but most of it goes from, it's a potentially life-threatening condition, so it can go from a very mild state to a very severe state. It can have cutaneous symptoms, it can have respiratory symptoms, it can have gastrointestinal symptoms, it can have cardiovascular symptoms, or CNS symptoms, or other symptoms, or any combinations of these. There are conditions that are considered not anaphylaxis, like shock. You can have hypovolemic shock, cardiogenic shock, you can have sepsis. Sepsis is not shock. Acute asthma is not shock. Syncope is, acute asthma is not anaphylaxis. Syncope is not anaphylaxis. So that's important to remember, what is not anaphylaxis. So now we're going to go into the phenotyping process. I have a link out and it's in the chat here, data.odyssey.org/Odyssey 10-minute tutorial code diagnostic anaphylaxis. You can follow along by clicking that link. The next set of slides are basically screenshots from this slide, and I'm going to walk you through this. As we discussed, we'll put a check mark as green, which means passes diagnostics. X means fails diagnostics. Then we have to do something about it. And it's all informed by cohort diagnostics. So let's start with something simple. Let's start with the concept set. We need a set of codes that we can apply on our data. We can build it through multiple processes, and I just talked about the VBA approach. For this particular example, I'm starting with something very simple: a SNOMED concept of anaphylaxis and its descendants. When I build a cohort with this combination, and you can see that in the app, it's yielding a good number of records, a good number of subjects. In these 5 US data sources: Optum EHR, Optum Extended DOD, Proven CCAE, Proven MPCD, and Proven MPCR. There are thousands of people that have met this anaphylaxis definition. Now, I'm going to give that a green check. That means that this particular definition, using this particular concept set, has yielded subjects for study across multiple data sources. Now, I'm going to go in the core diagnostics app to what is called as temporal characterization. It's a diagnostic that tells us what is happening to this group of people that met this core definition at certain time point. What we're looking for is on index date. That means on day 0, the date they were diagnosed with anaphylaxis. What happened? And I'm showing you on the right side the selections that I've made to come to this point. So there is the database selections, the temporal choice selection, and the cohort selection. And I've also selected on the top a domain. That filters the report to certain elements, in this case, drugs. I'm interested in drugs because as a clinician, I know what's the treatment for anaphylaxis. And when I look at the Optum EHR data source, I'm actually very happy with what I'm seeing right now. If you look, the rows, or the first one on the top is epinephrine. What's the first line of treatment for anaphylaxis? Epinephrine. If I see 52% of the people that were diagnosed with anaphylaxis to have epinephrine, I immediately feel good about this core definition because that's the standard treatment for anaphylaxis. You also see other drugs, diphenhydramine, an antihistamine, methylprednisolone, famotidine, prednisone, albuterol, sodium chloride. All of these are part of the treatment that is used for anaphylaxis. So yes, I like it. I look at another data source, in this case, Optum Extended DOD, and here I also see epinephrine, methylprednisolone, diphenhydramine, prednisone on the top list, slightly lower than the Optum EHR data source, and that's explainable. And that's actually something to remember. Optum Extended DOD happens to be a US claims data source, while Optum EHR is an EHR, electronic health record system. So the data capture is a little different, and that but the direction of these features are similar. So again, it reinforces to me that this is a good cohort definition for anaphylaxis. So I'm going to give it a check. Next, I'm going to look at the conditions domain. I'm going to go to the same drop down and instead of domain name equals to drug, change it to domain name equals to condition. And when I look at that in the Optum EHR data source, I see on the top line anaphylaxis. 62% of the people have anaphylaxis. But remember, this is a anaphylaxis and its descendant, so it has multiple concept IDs as part of the definition. We've got anaphylaxis, food anaphylaxis is the second one, allergic rhinitis, allergic disposition, peanut-induced anaphylaxis, and so on and so on. And that kind of brings a little concern for me because I'm interested in anaphylaxis in relation to a drug. I'm not interested in food anaphylaxis. I'm interested in peanut-induced anaphylaxis. I'm interested in a very specific subtype of anaphylaxis. So this makes me think, am I getting the right set of people to study here? This is an outcome definition. So I'm interested in the outcome of anaphylaxis after drug exposure. When I look at another data source, the Optum DOD data source, I see a similar trend, anaphylaxis, but followed by food anaphylaxis, 34%, 22% in Optum EHR. I'm going to mark this as an X. It failed my diagnostics. I need to do something about it. Now, I'll continue down and I look at procedures. Change the filter, I select procedure now. And when I look at it, the top few are therapeutic injection, prophylactic injection, collection of venous blood, ED visit, office. All of those are procedures associated with anaphylaxis. Same thing with the Optum DOD data source. So from the procedure diagnostic, I give it a check. But in my back of my mind, I have one diagnostic that this cohort has failed, the condition domain. Now I'm going to go to the next diagnostic there called cohort characterization. What this diagnostic is telling me is the distribution of the age and gender for this cohort definition. And what I observe here is the age distribution. There is a concentration of this cohort in the 0 to 4 age group and 5 to 9 age group. This led to some discussions in my mind. I'm thinking about it. Is this really the cohort I'm interested in? Because as you get older, the rate of anaphylaxis is getting lower. Well, that makes sense, but that makes sense in the context of a general anaphylaxis. Younger individuals, children, are more likely to suffer from anaphylaxis from environmental exposure like bee stings and peanuts and so on. As you get older, you're probably not going to be as susceptible or be less likely. So I'm thinking, looking at this, that this is more likely to be capturing people with environmental anaphylaxis, not the drug anaphylaxis. So based on that, I'm going to give it another fail. So now my core definition has passed several, but has failed two important diagnostics. So what do I do? Let me modify the concept set. Let me modify the concept set and exclude this environmental things. So if you go to the app, you can see a core definition where I have modified it. The box at the bottom shows anaphylaxis on the top, but then under the exclude column, which is the third column, I've excluded food anaphylaxis, anaphylaxis caused by venom, anaphylaxis is caused by substance, anaphylaxis caused by insect bite, and so on. I've removed some of them. When I ran this definition across the 5 data sources, the number of people that met the criteria now went down in the Optum EHR from 142 to 95,000, 241 to 123, 431 to 194, and so on. There is a drop. The drop is significant, but I'm not extremely worried about it. It's about 25% drop, but I'm maybe getting more specific people. When I look at the drugs, it still has that epinephrine on the top. So that's good. So I'm happy with the drug domain. That diagnostic continues to pass. When you look at the condition, arousing anaphylaxis, allergic disposition, essential hypertension. Food anaphylaxis is not on the top anymore. Food anaphylaxis still exists, but it's way down there in line number 10. And it's now about 5.4%. In the past, it was 25 to 30%. So I'm feeling a little bit more positive, and I'm going to give this a check. This is a good one. I could remove this. I could further tweak it, but I'm going to look at other diagnostics for now and come back to this food anaphylaxis later. I'm looking at the age distribution now. With this change, the age distribution has also changed. In the past cohort, the younger age groups had much higher rates compared to the older age group. Now I'm seeing a pretty uniform 6%, 6%, 6.4, 8%, 7%, 7%. This is in line with my prior expectation that drug-induced anaphylaxis does not have much age to age variation, while environmental does. So this is good. I like it. I'm going to give it another check. Now I'm going to go to another type of diagnostics. I'm going to go back to temporal characterization, but in this particular case, I have changed the temporal window from 0 date, which is the index date. I'm looking at the time period immediately prior to the index date, which is the -30 to -1 date. It's the column name for the last column on this screenshot. Okay, so what I see here is that epinephrine is still on the top, but I'm thinking, why is epinephrine on the top here? This is before the diagnosis of anaphylaxis. Why are people getting anaphylaxis, prednisone, methylprednisone before their diagnosis of anaphylaxis? This is what we call as index date misclassification. Now, because of the time limit, and this is a 10-minute tutorial, I'm not going to be able to tell you how to correct this X. So please join the phenotype work group, and there we'll discuss more about how to use cohort diagnostics to iterate and continue to improve cohort definition. Thank you.
All right, so that's a very quick overview of the cohort diagnostics. And the last, not but the least, is about ATC hierarchy on the drug for the drug vocabulary part by Christian.
ATC, how does it work? When to use caution? How you can use 10 minutes. What does it mean? It's called ATC because it means anatomical, therapeutic, chemical classification. It's 50 years old. Actually, it was started by somebody working in IMS, the company that I started working with before it was renamed to IQVIA. Being very successful, very mature, used all over the world. Okay. It is a stratified hierarchy. So you have the anatomic, first level is anatomical, for example, drugs for the skin, dermatologicals. Second is therapeutic, antibiotics or chemotherapeutics. Third level could be also therapeutic or pharmacological. In this case, it's therapeutic. Fourth level is any of the three. Well, they ran out of other useful categorizations in this particular example. And the fifth one is the chemical substance. Another case, metronidazole. Okay. That's an antibiotic which you can take, but it doesn't get ingested into the bloodstream if you take it orally. So, and in metronidazole, you have the same ingredient, metronidazole, and then you go down with the hierarchy, and there are all sorts of products. Noritate, metronidazole cream, 10%. Okay. So this is just any good drug classification that you would expect. That's how it works. You can use the that you would expect. That's how it works. You can use the
sorry, it's still loading a bit. Let me refresh. Sorry about that. Actually, I did not know the ATC was not from, I thought it was from WHO or something, but it was actually from the company. This is really technical difficulties. Let's see. My laptop, it's like,
Would it be easier if just open directly from YouTube?
let me see if I can do that. How do I?
For audio, seems like your internet connection is fine though. At least your
Yeah.
audio. Yeah.
I don't know if it just my left, like the
maybe
fan.
YouTube is down. Let's try.
Oh God. I think it was just got to be like, you know, the interesting part of ATC.
You can use the concept ancestor.
Oh, okay.
So
finally, it's working.
Yeah, the ancestors. You can.
Were we here? No. I think we're.
Any good
okay.
classification.
I think now it's loading.
That's how it works. You can use the concept ancestor. So here are the descendants. Here are the ancestors. You can stratify by the concept class ID, which is not this, it's this, ATC1, ATC2, ATC3, and so on. And it will work. You can find the metronidazole in dermatologicals and the other way. You can use the concept relationships. These guys are linked with the ISA connector. Between ATC5 and RX norm, there are special connectors, and of course, you know, you can get from the ingredient to the product. Usually takes you a couple of jumps. That's it. You're done. 10 minutes up. No, you're not. That would be nice, right? You have drug ingredients and you have a drug class, and it all works, and you can just rely on it blindly, but you can't. There are a couple of things that you need to keep in mind when you use ATC. And ATC is our main drug classification system, so everybody uses it, and it's used internationally widely. All right, metronidazole and the 4 ATC strata on top of it exists more than once. We are usually I don't show this in this tutorial, but here are the ATC codes, so they're all different. So metronidazole is there 5 times. What's the difference? Well, they're actually different classes. Okay, this is they're not bacterial microorganisms. It works against those very well. It can be used in a systemic way. You have to then give it parenterally. It can be used as local as vaginal creams, and you can use it in order to eradicate all sorts of nasty bacteria in the intestinal tract. Why is that so? Well, because they're different anatomics and also different pharmacological forms, which make this thing happen more than once in ATC. Not so bad. A hierarchy can have more than one parent, right? So There's one RX-norm ingredient, metronidazole, but there are a whole bunch of them in ATC. Kind of like, you have more than one parent, you have 5 parents. All we can deal with that, all good. If you're doing it, if you're rolling up in a co-medication, of course you get an over reporting, but other than that, we know how to do it. Well, it exists in combinations, fixed combinations. Okay, well, vonoprazan, amoxicillin, and metronidazole. See, there are whole lots of them, and they have different classes. If you go up the hierarchy, they exist in fixed combination inside a class. So betamethasone and anti-infectives. This anti-infectives, this can be metronidazole or different anti-infective. Okay? But there are ATC classes which have metronidazole containing drugs in them, and they can be hidden in this particular way. So there is an ingredient, different one, in combination with metronidazole as member of a class. Gets worse, lazonoprazole combinations. You don't even know it's an anti-infective. Can be anything. And finally, I love these, anti-infectives combinations. This is an ATC5 class. So if somebody tells you ATC5, they are ingredients, they're not ingredients. Sometimes they are classes. And ATC5 does not tell you what actually is in there. Well, it tells you. It's just a whole bunch of different things. Okay? So that's problem number 1. Problem number 2, it's actually no problem. It's a solution. Except you need to know this. We solved the problem of having a lot more than one. In fact, there are 51 metronidazole classes in ATC that can contain it. And so, but we only have one metronidazole ingredient, which is metronidazole ingredient. Okay. How do you do it? How do you make sure that this 83 class doesn't inherit everything in the grandmother that contains metronidazole? Because the hierarchy concept ancestry is no longer symmetrical. So it goes like this, and then it splits up again. So if you look down from this guy here, you will get the ingredient, but then you jump in this direction. You don't see the children, other than the ones that belong to this one. Same is true for here. And this works for all of the 51, and it works all across ATC. So don't be surprised if you do step by step and think, oh, I can do concept ancestor myself by just doing one step and the next step. You don't know anymore that if you descend from this step, you have to go this direction and not that direction. So please rely on the concept ancestor table. It will do that right. You can map from ATC. Why is that important? Because many source data use ATC as a drug coding system, even though there's all this ambiguity that I showed you. But we have it still. So you can use metronidazole local oral, that's ATC5, and it maps to metronidazole. Okay. If it's hidden in these combinations, it will not map to metronidazole. This one will map to betamethasone, because that's explicitly mentioned. This guy here, nothing is mentioned, which means it maps to nothing, because it can map to a whole lot of things. So we don't know which one it maps to. So when you ETL and you have one of these ambiguous ones, you can't just blindly throw the maps to table at it or source to concept map table at it. You have to figure out somehow else figure out what actually is it that's being given. It has holes. It has holes. I'm saying it again. It has holes. There's 600 ATCs that have no RX norm. That's 13%. What is this stuff? Usually old medication that isn't used anymore. But there are 30% of them. The other way around is much worse. So if you think you have RX norm and you just roll up in order to make a report, you're going to miss a ton. 74% have no ATC. 74% of Rx norm, by the way, Rx norm and Rx norm extension, of course, ingredient have no ATC. How is that possible? It's possible because ATC works passively. So the pharma companies actually have to submit to ATC saying, hey, I have a drug, please put it in ATC. If they don't do it, it doesn't happen. But again, this sounds worse than it is because the 74, most of them are all sorts of funny extracts and root tinctures and those kind of things. Okay, so your normal standard drugs that we tend to research in Odyssey, they are nicely covered by ATC. So the 74 is all all sorts of allergenic extracts, all these kind of things. They don't have ATC. So ATC is only proper chemicals. Okay. And by the way, the ingredients, it's worse than in drugs because there are a lot of ingredients in Rx-norm extensions which actually have no drug. They just got in there somehow, also historically, but there's actually no product. So only 37% of the drugs have no ATC. But still, you have to remember when you roll up into ATC, you're going to miss things. And you're going to have to remember, if you roll up into ATC, you're going to double count. Okay? So make sure that in your statistics, this is taken care of. That's it. Metronidazole is more than once in ATC. 35 out of 51 ATC concepts, the word metronidazole isn't even mentioned, but it's still in there. Don't forget that. There are these combinations and anti-infectives and other drug type things. We built a hierarchy to take care of this situation, so it's asymmetrical. The child of your child is not automatically your grandchild. It could be somebody else's grandchild. ATC5s are mapped to ingredients, but only if they are unambiguous. But if they're unambiguous, then they're well mapped. And ATC has holes. It doesn't cover the whole drug space that actually is contained in the name. Thank you.
All right. So thank you, everyone. So that's all of the 3 mini tutorials that we have today. And if you're interested, definitely go to the Global Symposium upload so that they have more in-depth tutorials on this. Cool. So that kind of wrap up. Oh, we have that echo. That wrap up kind of everything we have for today. And for our next APAC community call, we will have more information and a quick preview of the APAC symposium happening on November 18th. Please stay tuned for that. Thank you so much for joining us today. Have a good one.
Thank you. Thank you. Have a good day.
Thank you. Bye.
Bye-bye.